Hey there, it's Jason Gorman from Codemanship with a video about legacy code for JavaScript developers. So in this video, I'm going to be summarizing and demonstrating a technique, a process, an algorithm, if you like, for changing legacy code safely and over time rehabilitating legacy code to make it easier and cheaper and safer to change. Now, the process I'm going to be demonstrating is described in, as far as I'm aware, the only book still in print on the subject of changing legacy code. So let's take a look at that. Working Effectively with Legacy Code by Michael Feathers. Now, there's a lot of great stuff in this book, and there's no way I can summarize it in a half-hour video. So what you're going to be getting is very much the view from 30,000 feet. So I recommend taking a look at this book. It's got loads of good ideas in it. But there's a core sort of process that's described in the book, and I'm going to be giving you an overview of that now. So in order to demonstrate this, I'm going to need some legacy code. So here's some legacy code I wrote yesterday. Yes, you can have new legacy code. What makes this legacy code? Well, Michael Feathers' definition of legacy code is code that does not have fast-running automated tests. So that when we make changes to it, it could be a long time before we find out if we've actually broken the code. So it's not really safe to change the code. And this, we find, is one of the biggest contributing factors, probably the biggest contributing factor on how easily and quickly and safely we can change legacy code. So it's a big factor in the cost of changing code. So here's Michael Feathers' process for changing legacy code. I've got a little application here that prices video rentals based on their IMDb rating of the movie that we're renting. So if it's a high-rated movie, we charge more. If it's a low-rated movie, we charge less. Okay, so here's Michael's process. Step one, we identify what needs to change. So the business comes to me and they say, oh, Jason, we've decided to add a new band to our pricing logic. So now we've got this classic, we've got our premium, we've got our standard, and we've got our bargain, but now we're adding a classic pricing, which is another extra £1 if the movie has an IMDb rating of 8 or more. So the first thing we do is we identify, okay, what code do we actually need to change? So Michael in his book calls these the change points. Well, the code for actually calculating the pricing is here. So this is the change point. This is the code that we would wish to change. Once we've identified the change point, we then need to think about where would we want to write tests so that if we were to break this code, it would show up there. Michael called these inflection points. And what we're looking for is sort of stable interfaces within our application where if we were to write tests, we wouldn't have to keep rewriting them because we're refactoring those interfaces. But that also would give us some wiggle room so that if we want to do refactorings in this code, we've got a bit more room to play with in terms of what we can change. So we're not necessarily going to write tests for the price method of the pricer class. And in actual fact, when I've been testing this manually using a little command line program that I've rigged up here, I've actually been testing an object that uses the pricer, which is called rental. So we take a look at rental here. So this is the thing that I would be writing tests for, not necessarily for the pricer, but if this was broken, then it would show up here. These fields essentially would be wrong. The values would be wrong. So let's think about writing tests for our rental object. But we can't at the moment write unit tests for rental because we have, in our pricer, we have this code here, which is connecting directly to a web service to fetch the IMDb rating and other movie information. So we have a hard-coded external dependency that is in the way of writing unit tests for our rental object. So the next step in Michael's little process is that we break any dependencies that are stopping us from writing fast-running tests. So we're going to refactor this code so that we can actually inject an object that pretends to connect to a web service but actually just returns hard-coded test data. In order to do that, we're going to have to be super careful here. So I'm going to do a little refactoring. Let's extract this into its own method. Call that fetch info. Okay. Now, opinions differ here, and there are some people, in my opinion, silly people, who say, oh, well, if you use automated refactorings, you don't need to retest this code. I happen to disagree based on personal bitter experience. Automated refactorings, as we're about to find out in this little demonstration, are not guaranteed to leave the code working. They sometimes do things that we're not expecting. And particularly in a language like JavaScript, quite often we'll have to do refactorings by hand. And therefore, I am super disciplined and I retest. So I can retest this at the command line using my little program here. So let's run that. So this is essentially a manual test. And let's take the example of a high-rated movie first. So we're going to check that the price of that is £4.95 and that we're also getting the right movie title. Okay, there we go. Yeah, it's The Abyss, price £4.95. That's what we're expecting. And then I might then do that for a low-rated movie and a medium-rated movie as well. So those are the tests, if I was testing this manually, that I would want to run in order to give me confidence that the pricing logic is not broken. Now, I can speed things up a little bit. I've put together, knocked up a little Windows batch file here, so I can actually run this using the batch file for these 3 different movies. Okay, now, that speeds things up a little bit, but those tests still are relatively slow. They take a few seconds to run. And if I had lots of tests, if this was a more complex application, then it might take a while. But I think it is important to be super cautious at this point. There is a real danger that we'll break the code and not know it. So I retest manually if necessary. But those are, of course, integration tests in the sense that they're actually hitting the web service. And we don't want that to happen. The next thing we want to do to break this dependency is we want to get this in its own class. So let's take it out there. Probably easiest to put it here for now. And I'm going to call this class IMDb. Paste in that method. And then I'm going to replace the call here to what was a helper method on the same class to this method on this new object. So that's a single refactoring extract class, which I've done manually. Therefore, I definitely need to retest my code. Okay, we're looking good. That's all good stuff. Now what we want to do is we want to inject this in. We want to use dependency injection to make this dependency swappable so that we can stub it for our tests. So let's first of all introduce it as a field, which will instantiate in the constructor of the class. Okay, that's looking okay. And retest. Even if it's automatic, don't take no one's word for it. See the code work, even if you have to test it manually. And then what we're going to do is we're going to inject this in as a parameter to the constructor. So let's introduce a parameter. Now here we go. What it'll do is it'll take that expression where it creates an anonymous instance of IMDb, and it will pass that into the constructor from the outside, as you will see. But let's take a look. Rental now. So we're passing it in. That's all good. But like I said, just because it's an automated refactoring, it's not guaranteed not to break the code. This code is broken because it didn't add an import Now, at this point, what I'm going to do very quickly is I'm going to move this class into its own file. See why in a minute. Yeah. Paste that. Export it. This will make life a little easier for us. Go back to our rental object. So this is now in the IMDb module. And then, because we've done some more manual refactoring there, we retest. Still looking good. But we've got to rinse and repeat here. If we want to write tests for the rental object, that it's constructed correctly, we need to make all of this swappable as well. So it's a bit like Russian dolls. We're going to pass the IMDb object into the pricer and then pass the pricer into the rental. So the whole call stack, if you like, that whole collaboration of objects is constructed from the outside. Okay, so let's first of all Introduce that as a parameter, pricer. And again, now we go into our little test harness that I rigged up there. That's not been imported, so I need to add that import. We also, at this point, need to import our IMDb class. Right, Jason? Yeah. So we complete that refactoring and retest. So you can imagine if there are a lot of tests, or if you're doing this manually, that might take quite a while. But it is important to be disciplined, maybe not for every single refactoring, but on a very regular basis, retest the software that could be broken by the changes you're making, just to be sure. Okay, now we're at a point where if we wanted to, we don't have to pass in a new IMDb instance. We could pass in a stub, for example, that returns hard-coded JSON data to use in our test. So essentially to pretend to be the code that connects to the web service. Now, I'm going to pause the video at this point, and I'm going to write some tests. So this is the next step of Michael's process that he describes in the book. Step 1, identify the change points. Where does the code need to change? Step 2, identify inflection points. Some people call them test points. Where would I want to write tests? Look for those stable interfaces around the change points so that you're not writing tests that are constantly being changed because you're having to refactor that code. But also to give yourself some wiggle room, because when we are refactoring, we'd like to have more choice as to what we can do internally to create a nice little safe bubble there with your unit test. So, and then once we've identified the test points, we then break any dependencies that are stopping us from writing unit tests, any external dependencies, and then we write the test. So that's what I'm going to do now. Okay, so I've written some unit tests that reproduce the test cases that I'm interested in. So I've got a test here for a high-rated movie, an average-rated movie, a low-rated movie. I've also added a test just to check that the title's being retrieved as well from our JSON data, so the title should be correct. So this has given me confidence now that all of our bases are being covered here in terms of pricing and rental logic. Just run our tests. So those tests will pass, and you see they run very, very fast compared to those manual tests and those integration tests that I was using earlier. So already speeding things up, which means it's going to be much easier now in a disciplined, test-driven way to execute the fifth step in Michael's process. Once we've essentially made the change easy by refactoring the code and writing unit tests, now we can make the easy change. So step 1, identify the change points. Step 2, identify the inflection points or test points where we'd want to write tests to give us confidence that we haven't broken the code. Step 3, we break any dependencies that are stopping us from writing unit tests. Step 4, we write the unit tests for the existing logic. And then step 5, we make the change that the business is asking us to make. So I'm going to do this in a test-driven way. So we're, oops, don't want to do it there. Let's put it here, it would make more sense. So we're going to add a new pricing test case. So it charges, let's call it a VIP price for a classic movie. A classic movie is one that has an IMDb rating of 8 or more. So very highly rated. And again, we're going to work backwards. And we'll look at the anatomy of these tests in a minute. The moment, so it should be £5.95, so it's £1 more than a high-rated movie. So as I'm writing this test, you'll see what I've done here. So there's our rental. So we create our rental object. We pass in an instance of the pricer object, and into the pricer object, rather than passing in an IMDb instance, what we're going to do is we're going to use a stub. And I've created a little helper function here to make that easy. So we're just creating an object there, very, very simple. And that's got a hard-coded implementation of the fetch info method that just returns the JSON data that we tell it to return, the title and the rating that we're interested in. In this case, it doesn't really matter what the title is. So an empty string is fine because we're not interested in the title, but we are interested in the rating. So we say 8 or more. So I'm going to choose a value that illustrates where that boundary is. In this case, it's 8. So we can read the test and go, okay, so 8 or more. And when I run this test is going to be our failing test, our red light in test-driven development. Okay, there we go. Cannot read property of price is undefined. I know why that is, because the rental also needs an IMDb ID. Now, there is no such movie, of course, but it doesn't matter what the IMDb ID is because we're not actually connecting to the IMDb API. It's kind of irrelevant, really, to the question. But we can just feed any old nonsense will do, as long as it's a string. Try running it again. Okay, so now it's failing for the right reasons. It's expecting 595, but the current logic doesn't know about classic movies. It only knows about premium movies. So it's returning 495. So we then very simply make the change that we want to make. So if rating greater than or equal to 8, having a little think now about how we're going to do this. So we have £2. Oh, in actual fact, no, I just thought of a cleverer way of doing this. You might have spotted it. We do 7 first. And then we do 8. So we just add another £1. So if it's more than 7, we add £1. If it's more than 8, we add another £1. And that works. There you go. So identify what code needs to change. Identify where you want to write unit tests to give you confidence that you haven't broken that code so that you can make that change in a disciplined and safe way. Refactor the code to break any external dependencies that are stopping you from writing those unit tests, and then write those unit tests for the existing logic, and then in a disciplined, test-driven way, make the change that the business is asking you to make. That's what we've done. And at that point, you could think, okay, we're done here. But I'm not entirely convinced that we are done. While we're in here, we could make like good Boy Scouts and leave the campsite area cleaner than we found it. So this is called the Boy Scout rule in software development. So while we're in here and we've got these tests now, so we've got a bit of wiggle room here, we've got some safety, maybe we could do some other refactorings that would improve the code for the next person that works on it, which could be me, for all I know. So while we're in here, let's see what else we can do. Well, I don't think, again, I think this method is still doing more than one thing, so I don't think this belongs in here either. So let's call it a parse. Sounds reasonable. And that belongs in its own class. So let's cut this. Call this a movie parser. Okay, and we're going to use that. Oh. Rerun our tests. Now this is much, much easier because we can test it straight away. Basically, we get the feedback straight away. So it's much safer, much more comfortable to do this now. And make that a field. And we can have that passed into the constructor. So we're essentially composing the price out of these objects. This automated refactoring will break the code, so we need to go into our client code now, wherever it is. So the tests, for example, you'll see there, we need to export that. Now, what I haven't done here, let's just go back to our pricer. We don't want that in this module. We want it in its own module. So let's do that now. So each of our modules has a single responsibility. We're doing here, we're saying we'll export that. Should be able to go back to our test code and import it easily now. Rerun our tests. Tests are all passing. So while we're in there, we make some small improvements that will make the going easier for other people who are working on this code at a later date. And over time, what happens is, as we're writing more and more of these tests, our test coverage starts to build up, and that makes working on the code much safer and faster. But also, as we're cleaning up the code, applying the Boy Scout rule, the code gets easier, hopefully simpler, easier to understand, and easier to change, which means that overall, and we tend to find this to be the case, as we're making one change after another change over the days and the weeks and the months, it's a slow process, I appreciate. The legacy code base that is risky and expensive to change becomes much easier and cheaper and safer to change. And I've seen some big legacy systems over the period of a couple of years of applying this technique essentially be turned around into a going concern again. So whereas at one point, all they were doing was basically bug fixing because it was just too risky and expensive to make any changes to that code. And therefore, the code was holding that business back because they couldn't change the processes or the operations that were using that software. But over time, as the test coverage built up and we were able to test more and more of it faster and faster, and as the code got cleaned up and the dependency problems were dealt with and it was simplified and made more readable and all the rest of it, it reached a point where the cost of making changes to the code came down enough that the business started asking for new features. So they'd had a whole bunch of things that they would really want to change but couldn't or wouldn't dare to. And now they felt, actually, we could do that. That becomes possible. So this is the process that Michael recommends in his book. It is a very effective process. It is far more effective than what some teams do, which is essentially just stop development and then speculatively refactor legacy code or write loads and loads of unit tests or whatever they think they do in the hope that that will make change easier. Those kind of refactoring sprints or refactoring phases, the results are always very disappointing. You need to refactor with a purpose, and the purpose is to make the changes that the business needs. So this becomes part of the process of making changes for your customer. And over time, this process will turn that code base around. And I find actually it's a very satisfying process. A lot of developers do not like working with legacy code. I happen to find it very cathartic. It's a bit like popping bubble wrap. So I really enjoy it. And you learn a lot more about design by refactoring legacy code, for example, to make it unit testable, than you do doing designs up front. You learn a lot more about how to design code from dealing with code that is badly designed, that is poorly designed, legacy code, than you do about trying to just design code or write code in the first place. So developers who work a lot on legacy code tend to have much clearer ideas in their minds about what is easy to change and what is not easy to change, because they've seen it for real. They've had to fix the problems. Now, I'm going to give you one final piece of advice here. So the process that we've just done, refactoring the code to break dependencies, writing unit tests, making the change in a test-driven way, so we wrote a failing test first, and then refactoring the code a little bit more just to make it a little easier for the next person. Never, ever talk about that process with your customer or other non-technical stakeholders, Because here's what will happen. If you say, oh, okay, to make this change, I'm going to break some dependencies and then I'm going to write some unit tests, and at that point, the customer will stop you. 9 times out of 10, they will stop you and say, oh, don't bother with that. Don't bother doing it in the disciplined way. Don't do it in the safe way. Do it what they think is going to be the fast way. But of course, we know that downstream, you're going to be costing yourself a lot more time fixing the bugs that you've introduced when you try to make the change in a non-disciplined, non-safe way. So you're going to save your customer a lot of time and money later by being disciplined about it now. But if you give them the option, if you essentially make that a line item in your estimate, okay, this long to write the code, this long to write the test, this long to do the refactoring, they will veto the disciplined stuff and they'll say, no, just make the change. My own experience is when I just make the change and then we try to put it into production, I end up spending a lot more time later fixing the stuff that I've broken than I would have spent writing tests and refactoring. So my advice is to just do it. If it needs to be done, just do it. You'll be doing your customer a favor, but it's a favor that they will not understand. More often than not, if you give them the option, they will veto it. So do not have that conversation. If it needs to be done, just do it. I put my hand on my heart here. I wish I could give you a written guarantee of this or a legally binding guarantee, and I can't. But you're going to have to trust me on this. It's not, in the long run, going to take you any longer to do it in the disciplined way. If anything, it might even take you less time, but it's not going to take you longer, and certainly not much longer or noticeably longer to follow Michael's suggested process. So there you go. That's legacy code. That's how we change legacy code safely, and how over time we can rehabilitate legacy code and bring it back into the fold to make it something that can be changed safely and cheaply for the business. You need to be patient, and you need to be, the kind of person that just does it. Don't ask for permission. If you ask for permission, permission will very likely be denied. And then that's not going to help you, and that's not going to help your customer. So don't give them the option to make the wrong choice. You should never do that.